Hello friends, I'm Sandeep. Welcome to my YouTube channel TechnoSide and welcome back to our Arduino tutorial series. In this video, we'll take closer look at different Arduino board models and explore their unique features. We'll understand the capabilities of each board that will help us to choose right one for our project. We'll cover the Arduino Uno, Arduino Nano, Arduino Mega 2560, ESP8266 Wi-Fi module, Node MCU ESP8266. These are the boards which are generally used in the projects. So we'll start with the first Arduino board, that is Arduino Uno. We'll see what are the specifications and features for Arduino Uno, and then we'll go for the pinout. Now whenever we talk about this Arduino Uno, it is one kind of microcontroller board which is based on Atmega 328, and this Uno name came from Italian term that means one. Okay, so what are the different specifications? Like in this Arduino Uno, we are having one microcontroller, and that microcontroller is nothing but a Atmega 328P. So second architecture which is supported is AVR family architecture. Operating voltage which is required to operate this Arduino Uno is 5 volt. So 5 volt is required. Then input voltage that can be given to this board is 7 to 12 volt. Digital input pins are total 14. Out of that 6 pins are PWM pins. In the particular Arduino Uno, we'll see which are the PWM pins. Analog input pins are 6, through which we can give analog input or we can connect different analog sensors with these pins. Then we are having flash memory which is of 32 KB, out of which 0.5 KB will be used by the bootloader. Then we are having static RAM of 2 KB, EEPROM of 1 KB, and the clock speed for this particular microcontroller is 16 MHz. Now we'll go to the pinout of this Arduino Uno. In this already we have seen that operating voltage that is required is 5 volt. So for that we are having power pins on this Arduino board. Then input voltage which is required. For giving input voltage, again we are having DC jack or barrel jack. And again, if you want to connect different sensors with the Arduino Uno or different actuators, then we are having digital input output pins. So we'll take a look at the components which are available on this Arduino board. First of all, we are having this USB connector here. So we can use this USB connector to connect our Arduino with our system, that is whenever we want to perform serial communication in between our IDE, that is Arduino IDE, and our board, then we'll use this USB port which will be connected to our computer. Then this is nothing but a DC jack which will be used to give power supply. Okay, so we have already talked about this input voltage that will be given with this particular DC jack. Then we are having different small electronics components which are available on this particular board. We'll see later on. Here we are having reset button. Whenever you want to restart or reset your Arduino Uno, we can use this particular reset button. We can click on that and we can reset our Arduino board. Then we are having these pins on the top and these pins on the bottom. We'll understand what these pins are. First of all, we are having power pins on this side. These are the power pins, 3.3 volt, then 5 volt, ground, 2 grounds are available, then V in pin, these are power pins. Beside to this, we are having analog input pins. These are only input pins. So A0, A1, A2, A3, A4, A5, these are the 6 analog pins on which we can connect any analog sensor. For example, temperature sensor is analog sensor, potentiometer is analog. So we can connect this type of sensors with these analog pins. Then at the top part, we are having different input output pins. These are called as digital input output pins. So pin number 0 to 13, these are total 14 digital and input output pins, out of which 6 pins will act as a PWM pins. Now what do you mean by these PWM pins? We know that here we are using this analog input pins for taking analog data as a input, but there is no provision to send the analog data as a output. So for that purpose we are having these PWM pins which will act as a analog output pins. Then we are having ground here, and pin number 0, 1, 2, 3 like this up to 13, these are the digital input output pins. Here you just see this LED which is inbuilt LED, and it is connected with the pin number 13. So whenever we want to take some output with this LED, we can define this pin number 13 in our program and we can use this LED. Then we are having these two pins, that is TX and RX. These pins are indicating us, these TX and RX pins indicate the transmission and receiving of data through this USB. Whenever we transmit any data from USB to computer, this TX will blink, and whenever data is received from computer through this USB to this Arduino board, then RX will blink. Then this is one more LED which is we can say power LED. Whenever we connect our Arduino or whenever we provide power supply to our Arduino board, then this LED will be on. So next, this is IC for Arduino Uno, that is Atmega 328P. So this is the IC, integrated circuit or microcontroller for the Arduino Uno. Then already we have seen these are the power pins. Here there are few resistors which are mounted, capacitor. This is crystal oscillator of our Arduino Mega. Then these pins are ICSP pins, also called as in-circuit serial programming pins, which are connected with this microcontroller IC. Whenever we want to change firmware or any programming of our microcontroller, that can be done with the help of this ICSP pin. Then here few more ICSP pins are available which are connected with this USB interface. So for interfacing our USB with Arduino Uno, we use this ICSP pins. Now whenever we check here, so we are having this fuse. This fuse is for the USB connector. Then we are having few regulators here. So one of the regulator is for 3.3 volt and one of the regulator is for 5 volt. Again there are few pins which are called as I2C pins, which are nothing but a integrated circuit pins. This I2C is a serial communication protocol, so we can transfer data bit by bit along a single wire on these lines. So there are two pins, SDA and SCL pins, which are used as I2C pins. Here if you just check, these two pins are used as I2C pins whenever we want to transmit data or whenever we want to perform serial communication. Then again we are having few pins for serial communication. Those are called as SPI, that is serial peripheral interface. So these are the pins again which are also used to perform the serial communication, like we are having SCK, STK, then SS pins, MOSI and MISO. So these are the pins which are available under this SPI. Now we need to understand what is the significance of this I2C and SPI pin. So whenever we want to connect serial devices or whenever we want to perform serial communication between the device, or we can say sensor or our Arduino Uno, at that time we can use this I2C or SPI pin. So whenever, like for example, whenever we want to connect LCD with our Arduino, so there will be serial communication in between our Arduino Uno and this LCD board. So at that time we need to use this I2C or serial peripheral interface pins to perform serial communication. So this is nothing but a pinout for the Arduino Uno. We have seen different pins which are available, different components which are available on this particular Arduino Uno. Now we'll go to the next Arduino board, that is Arduino Nano. So whenever we check the specifications of this Arduino board, so again the microcontroller family that is used is Atmega 328P. Then architecture which is supported is AVR. Then operating voltage which is required for this particular Arduino board is a 5 volt. Input voltage can be given as a 7 to 12 volt. Digital input output pins which are available are total 22, among which 6 pins are PWM pins. Analog input pins are 8 here. Then flash memory is of 32 KB, out of which 2 KB is used by the bootloader. Then static RAM 2 KB, EEPROM 1 KB, and clock speed for this particular Arduino Nano is 16 MHz. Now whenever we check the pin out for this Arduino Mega, here you just see digital input output pins. So pin number from D2 to D12, these are the digital input output pins which are specifically used to take digital data as a input and to give digital data as a input. Then we here at the center we are having reset button, and this is our microcontroller 328P MCU, and this is USB connector through which we can connect our Arduino Nano with the computer. Here at the right end we are having ICSP pins, in circuit serial programming pins, which are used to change the programming of this microcontroller. Then there are few LEDs which are mounted. So here we are having these 4 LEDs which are mounted here. So first at the bottom this LED is connected with the D13, that is inbuilt LED we can say, which is connected with the pin number 13. So this is digital input output pin 13. Then second LED we are having power LED. Then third TX, whenever data is transmitting this LED will blink, and whenever data is receiving RX pin will be blinking. So these are the LEDs which are available on this particular Nano board. Now there are different power pins which are available, like here if you just see 5 volt, here we are having reset pin, ground pin, and then V in pin. These are the power pins which are available. Again we are having one more ground pin over here. Then we are having analog input pins which are from A0 to A7. Total 8 analog input pins are there which are used to take analog data as input from the analog sensors. Then we are having 3.3 volt here and analog reference pins at this side. So these are the pins which are available. Again for serial communication we are having RxD and TxD pins which are used to perform the serial communication. Whenever we want to connect any serial device with this Arduino Nano, we can use this RxD and TxD pins. So this is nothing but a pin layout and specifications for Arduino Nano. Now next microcontroller is Arduino Mega. We'll see what are the specifications of this Arduino Mega. First of all, the microcontroller which is used is a Atmega 2560 microcontroller. Then it supports the AVR architecture. Then operating voltage which is required is a 5 volt. Minimum 5 volt we can provide to this microcontroller or this board to operate it. Then input voltage that is recommended is from 7 to 12 volt. Digital input output pins to connect different sensors, digital sensors, are total 54. So we are having, as compared to Arduino Uno and Nano, we are having more number of digital input output pins. Among these 54 pins, we are having 15 pins which will act as a PWM pins. Then we are having analog input pins 16. So here A0 to A15, total 16 analog input pins are there through which we can connect analog sensors and we can get analog data as input to the microcontroller. Flash memory which is available in this microcontroller is 256 KB, out of which 8 KB is used by the bootloader. Static RAM is 8 KB and EEPROM is a 4 KB. Again, whenever we talk about the clock speed of this particular Arduino Mega, it is 16 MHz. So at the right hand side we are having this Arduino Mega. So we'll go one by one and we'll identify different pins and different components which are available on this Arduino Mega. First of all, this is USB connector through which we can connect our Arduino Mega with our computer. Then this is crystal oscillator which will decide your clock speed, or which will perform the time synchronization for this microcontroller activities. Then we are having this DC jack. With the help of this DC jack we can provide 7 volt to 12 volt power supply to this Arduino Mega. So we can connect our battery, we can connect our Arduino, and we can provide power supply to this Arduino. Then there are different resistors, capacitors, and different small electronics components which are mounted, so that the particular microcontroller should operate properly. Then here at the bottom side we are having power pins. Here we are having 3.3 volt, 5 volt, 2 ground pins and V in pin, and 1 reset pin which is available. Then if we talk about the power pins, again here we are having one more ground pin near pin number 13, and here we are having 2 5V pins, and at the bottom we are having 2 ground pins. These can be used as a power pins. Then we are having 54 digital input output pins. This will start from 0, pin number 0. 13 pins are here. Then from 14 to 21 we are having these pins, 14 to 21. Then from 22 to 53, so side by side these pins are available, 22, 23, 24, 25, like this up to 50 to 53. These are the total 54 digital input output pins which are available, which are used to connect sensor and to take data input from the sensor, or to send data as output to any sensor. Then we are having analog input pins which are from A0 to A15. Total 16 analog input pins are there, to which we can connect analog sensor, and we can get analog data as input through these pins. At the center we are having this chip which is nothing but a microcontroller at Mega 2560. These are the ICSP pins, in circuit serial programming pins, which are used to change the programming of this microcontroller. Then again, like Arduino Uno, we are having reset button over here. Then this is the power LED which will indicate whether power is available to this Arduino or not. Then these are the ICSP pins which are used for this USB interface. So these are nothing but a pins which are available, and components which are available with this Arduino Mega, and we can perform different type of operation with the help of these particular components and pins.